Hello, I'm David Holt from University of Southern Miss, and we're going to be working with Screening Eagle. So we've got our workspace here. We've logged into our particular account. Screening Eagle is an adaptation of Slice, GPR Slice, and it's based out of Switzerland. So basically we're running these data through there. So there'll be a little bit of lag on some of the data sets we're working on. But we're going to bring our GPR data. So we did a snake survey, which means that we zigzag back and forth across this cemetery, ideally with at least 2 passes per row, in some cases 3. So we made roughly 1 meter passes through this one, which I like to do when there's a larger cemetery. So we ended up with 46 passes of this particular cemetery and about 75 meters per pass. So I think we covered just under 3 miles of survey in this particular case. So when we open this up, we need to upload this to our project. I've already uploaded it, so save on time. It needs to be zipped in your file, so you zip all of your data together underneath one folder, upload it, and then that will bring us into the data set. So we're going to open this up, and you'll see that we are working them at the speed of the internet, so we've got to communicate back and forth through it. But we are running off of a pretty high-speed computer there in Switzerland, so once we get this running, the processing happens pretty fast, actually. So we're reloading this particular project, and you'll see that we will use our GPS data. So we use the RTK. We had sub-decimeter resolution the entire time, so no lines were advanced unless we had fix, and we had to go around lots of different curbed grave sites and the like. So we pulled it all up there. In the first part of this video, we looked at imagery, because you can see that in this case I've already turned the position imagery on so that we can see where we're located. You can see it's a little bit grainy here, and I was really hoping to get 6-inch imagery, but where we're located, we just don't have that luxury. So I'm going to go ahead and turn this off for now, just so that we have our data set. No, I'm actually just going to, I'll leave it on because I don't think it's not going to affect us too much. So when we're processing our data, one of the things we want to find is we want to make sure that we've got some areas of good signal here. So line 1 ran all the way across the cemetery. Then we've got a zigzag here for number 2. Then we came back to do number 3, coming back this direction. Then we alternate all the way back and forth. So here are all of our data sets. We actually have 47 lines that we passed. We didn't have to delete any. All of them ended up working out pretty good. So you'll see when we opened up, we did a lot of automatic processing. So we do our wobble removal, which tries to take tracks of our pitch and our yaw as we're moving along. We time 0, so the gap between our antenna and the ground through the plastic is removed. You can usually see that by this nice clean line on the top. This is our slice up here. I'm just going to move it down here. So we don't have any big black gaps up here. We can see some areas where we had to come up and over the curb where we do have that as a problem. But so when we do our slice, this is going to show us what we're actually focusing on, but we've only done the auto processing here. We trimmed the data off for anything that runs beyond our scope here. We're just using pins to identify our start lines there, so a little bit of a zigzag here, but we're starting roughly where the pins are, and then we're using I think 5 pins across. So as we come across to a pin, we move it to the other side of the carriage, which gives us about a meter pass. Some of these things had to shift because you can actually see here where we have lines coming really close to each other, because the headstones were not out of alignment, but they weren't parallel to each other. So we had to shift the lines one way or the other to get around those things. But we're going to come back. We're going to look at we did an automatic background removal. That's for the entire set. So if there's a constant signal coming through, we're looking at the first line here, and we can see that we've got a lot of interference. The interference is coming up from the bottom here. So any of these signals that are coming up, these pulses right here, typically we get a lot of these from radio frequencies. They can be police, any sort. I'll show you the bandwidth. We're covering a lot of bandwidth here. There was a cell tower pretty close by. I am using a cell phone that has wireless connection to the internet. so that I can get my RTK corrections. Otherwise, that's going to cause a problem with our processing. So we can come through here and we can actually, we can root our wobble removal. I usually leave it at the default 51. Our time 0, threshold is fine. And basically this is removing any of the lag signal that we're getting. Our trim data, and I usually let this populate from our N, and so it will vary depending on how long our lines are and what the average length is. We've got a bandpass filter. This is the first thing we're going to look at. We can see that right now our bandpass filter is, we capture data from 16 megahertz all the way up to roughly 3,700 megahertz. So if we look at our instrument is actually at 400 megahertz, but you can see that this is the 400 megahertz signal there, is peaking right there. So I want to make sure that I'm capturing all of these, and I find when we're looking for human remains, right about 250 to about 550 is a good range statistically to get those back. So I'm just going to get those really close to that number. And then as I process through all of these different data, I'm going to see if I am picking up early stuff for light. So this is looking at the entire signal. There's a little interesting little peak here going on number 3. So it looks like I can come down to 187 here if I want to capture all of that. But my experience, again, I'm going to probably leave it around 200 to 500, 200 to 600. So about 200 megahertz above, 200 megahertz below is fine. I've even brought that in even more. Now, how I know if that's going to be good or not is as I run through here, I want to see to make sure that what my frequencies look like. Like here's an interesting one here that actually the band passes are coming in a little bit lower than that. And so I'm looking at there's a bimodal distribution there where the signals are coming in. So I've got some good ones right here. I've got some good ones right here on 1 and 3. So I'm going to use this to calibrate myself here. So before I cut that off there, I want to find out the rate in which the signal is coming down so I know how deep we're dealing with. So the way that I do this is I add in my velocity. And so this is how I set my hyperbola. So I come up here and I start my hyperbola system there. I can select the center dot. I'm going to go over one of my targets. So here's a good signal target here. And then I'm going to grab these guys and I'm going to move the target out so that it hits that particular bandwidth. Now by moving this, it's going to change my frequency. So this one is a white target here. I could change my signal here down as we move down at depth. And I can hit done, and it's going to recalibrate that. So it's saying it's at a 6.9 at that particular place. But that's not necessarily the greatest signal there. So let me find a really good black-white signal here that we've got a good target. All right, so there's a nice target sitting right there, not a wide one. We're going to come back in at our actual target. Remember with these triplets are showing us the target is actually right there where my crosshair is. So I'm going to come in here. This is my anomaly. Line up my anomaly to the center of that. Follow the legs of the hyperbola. Line up those legs there. We're going to see how that velocity is, and this velocity is hitting a dielectric of 4. So he asked me, he's like, well, what dielectric did you start with? What dielectric are you going to be happy with? Well, we're in a dry soil. It was a pretty mixed soil. There was clay, so it's kind of loamy. So I'm switching over here. This is a paper from 74 that's actually using data from 71. So Lundian 66. So these are all different studies of what dielectric constants they had in a loamy soil. So this is just a really quick search. This is a pretty good article here because it's got sand, it's got all sorts of stuff here. So we're looking at all these silt loams and that, and kind of the frequency there. As you can see that 3 is about the lower end, so we're hitting about 4. I ran the study at 6, but we have to calibrate that when we finally get in there. So I'm using these charts and these different soil types, and just really quickly, we can find a couple others. So all the math that's behind all of this fun stuff here. So here's looking at sand, where they're different dielectrics based on if it was dry, if it was wet. We can run these calculations, but really quickly, this is just dielectric properties of soils as a function of moisture content and how we change. We did have a little bit of rain the day before, but it was it doesn't look like it really hit the Sontag area significantly. It was very patchy. But here's a good article there. So there's reasons that we're choosing this. And as I look at the dielectric there, it is following 4, which is a little bit low. It calibrates my depth. So now I can see that this target right there that I'm lining up, you can see the crosshairs sitting right up here. So one of the first grave sites that went over there is sitting at the top of it is just about 1 meter down here. So we found some that were pretty low and some that were pretty deep, that sort of thing. So we're going to calibrate that. Now I've got my 2 targets here. Find another good one. There's one here. So I like to go to different parts of the cemetery. So I'm going to look at this part. I'm going to look at this part. And now we're going to do my band filter to see if that signal is going to improve. Now, the advantage of doing this online is this computer is going to be able to run all of those processes and calculate them. So you can see that this tightened up a little bit, and my signal's getting a little bit cleaner there. I still got some interference coming in from various towers, but it is clearing up in other areas here. So this is running this this bandwidth here. We can come in manually if we like. 250 to 550 I've used in other cemeteries. We'll just run that one to see if it fits nicely. And you can see it was just a little bit of a tweak there. We can see these guys. So as we look at our target here, we've got a known target here that's definitely a return, and then we've got it. This is the signal coming down through, and we're hearing it again and again. It comes down, so it's a bit of an echo. But as we clear up some of this background noise, we've also got some other interesting ones here. These are what we call medium or even low. It depends on what that signal looks like over space. And this is really where the time slice is going to come in handy for us. So there's our bandpass filter. We can do a background removal by pulling off traces here, but we're not going to worry about that so much. We can do our auto gain curve, which we can do by line, so we can curve it by line, or we can do an average of the whole cemetery, or we can choose which line we'd like to do it. I'm going to go ahead and leave the auto gain alone now. I'll probably play around with that to see if we can get better data sets there. We can change what our imagery is looking, so how these things are scans, and you can really see we can change whatever color we want, but sometimes these are really useful to show us what we're looking at. So this is which of our envelopes is what they're calling in this particular process here. So as we come down here, we can also do our live gain, which we're going to end up doing an auto gain preferably. But as we run through these, it's usually good to look at both of them together. So as we see what our signal is here, we can also come back and we can check it. So here's our distance across the surface there. So let's move in and do our data sets up here, and you can see where we've got our signals. We ended up getting a bit of a gap here because there's headstones on either side here, so we ended up running a gap there. So 2 passes there, 2 passes there, then we ended up with these passes, and this is on the back side of the cemetery to see what we can get. So what you're looking at here, so we're down about half a meter to a meter. You can see this is where our locations are. So you can see that they are, the presence is important, but the absence is also important. So we want to make sure that we're finding anomalies, but we're also finding non-anomalies. So here's no burials. There's clear burials, here, and here. And we can actually put those physically in space as we need. You can see that we're in our imagery back here, even though it's a bit grainy. And we do like it a little bit better. So let's going to turn off our let me see, we'll try to turn off our lines. So we can, I think I'm going to turn off the slice. Oh, no, I have that one highlighted. Okay, sorry. So let's turn off these lines here. I can come back and actually look at the individual lines here. So this just makes for a little bit easier of a visual clue of what's going on. So let's run down to further down the scan. So we're going to come to more of a modern era, just zooming in and out here. Well, I shouldn't say modern, so but the closer to. So we ended up with a decent amount of noise here. So we can find out where this one's located, and you can see this is actually out on the edge. That's running into the tree, so I'm going to try to find a better location. So this one is actually showing a very shallow grave site there. So this is probably a vaulted one, so I'm going to try to find a better one. So we're doing this live. So I'm just trying to find another line of positive returns. Yeah. And so, yeah. There we go. That was always good when we were doing a recording. I was looking down between 2 to 4 meters. I was wondering where all my burials were. They're up here between 1.5 to 1.5 meters. So there's all our burials. So we look at these guys. Okay, we've got a deeper one down here. And so here's a good example of a burial that is going to be a medium confidence level there. I can come in and check my dielectric again just to make sure that my impulse is coming in pretty good. So we're looking at the second solid signal there, and I'm going to pull these guys in here and see what the dielectric of that particular one is. So it looks like we're changing our speed value there, which is interesting, that we've got a soil type change. It's probably because it's really forced on one end and not on the other. We can run through, but we're still inside of our known areas here. So let's come back here, and I'm going to verify that dielectric signal. That is a bit of a jump, so I'm going to come back in here, and we're going to check one of these more shallow ones. Yeah, it looks like I may have overdone that one. Yeah, you see we're dumping back to 4. So if we look at this particular one, we can double click on it, and it's going to center us up there. And then I can bring down our target, and you can see where these higher burials are. As we move down, you can see where the burials are coming in and they're going away. So we can come in there and flag these guys for a mapping process. We come back to one of these deeper ones. So there's one that's seeming pretty faint there, but this has to do with the color that I'm using up here. So I usually like to peek these guys out so that we have strong evidence on where the outliers are. So we can flip this around, and you can really see where at this layer where the high signals are. These are the really hot signals coming in, and then we can move through our layers of where the people are locating. Zoom out a little bit so we can see the whole cemetery. But this is the process that we went through. So you can really see these hot signals there. So really about 2 meters. Anything above that, we're actually getting a pretty standard signal there. So we look at it's getting darker. Those darker areas are going to be our medium confidence levels. Then we're starting to get a lot of different things as we move over the top. So we really want to look underneath the surface here about where our barriers are located. This is one of the first ones we did, so it's located down here. And we can zoom in to see what that individual guy looks like here. So here's another good one over here. So I can click up here, and it will bring me to that particular target. So you can see we've got a really strong target on number 8. I can switch over here, and we'll go to number 8 again. And so we're now looking at that signal both at our target reflectivity, and then we're also looking at our hyperbola down here. So coming up and over our coffin here, coming up over there, so you can really see this target, and then we've also got a softer target right behind it coming over there. This is noise coming from the surface. We can also still see evidence of the top layer hole being dug, so this is probably a more recent burial site there. So anyway, that is most of the processing there. We can go into a little bit more detail about trimming these things down. What we're looking at, we could play with the auto gain line by line, or if the averages are going to be better. And just for posterity's sake, I can show you. It's always fun because all of these move slightly different. So I'd like to do, a line by line, because if the soil type change, which it seems like it does, we can have it calibrated. Now, we didn't see much of a change here, but that's because instead of using the average gain for all of it, this basically means if it's harder to hear down lower, we can kind of pick up that signal. And if it's weaker at the top, so it allows us to kind of identify objects deeper down here. So there's another good one here. So we've got a series located here. So two buried next to each other. It's inside of our current slice there. So if I move up to the top here, we can now see the slice of this one here. So we look at it by creating these flat layers as we move down. And again, I can come over here, find where this one was, and then we can move to what this looks like on the other signal. So I've got a 1, 2, 3, a strong 1, 2, 3 here. We've got another one that's kind of a similar kind of return here. And this is where we're looking at. We've got a really faint return over here. This would be a low confidence at best on this side here. But we're looking at this one here. We've got a high confidence, high confidence, high confidence. This one's pushing more of a medium confidence here. But because it's located so close to this one, we're actually starting to see some kind of trending there. So that one would have been flagged as well. So that's where we end up with the different colors but as these targets. There's a lot of interpretation, as you can see, in this whole process there. But I've gone on quite a bit there. But anyway, to look at the processing, we can come in and we can look at our particular slice methods. We can do we can build up our slicing, and we'll do that more in the lab if we look at that, about how we can tweak these sorts of things to look at. I'm not going to do it right now because it changes your data. We got to start all over, and I'm not going to do that right now. But as far as our positioning is concerned, we're using UTM positioning coming in is tying directly into our GPS. We can offset our antenna location if we need to. We can also do our correction for Z, or roughly how high our cemetery or our GPS receiver was, and it's 1.43 meters above the ground. So if I run that in there, it will actually just calibrate. So it doesn't change our depth here, but it changes our elevation model. So we can put it into a 3D model if we actually need to, and we can tie in all of these other types of data as we need. But with that, I'm going to stop off there, and this is kind of going to end my report for running out there. So this particular survey for this area took about, I think we did about a 2-hour run, then we took a break, we got another 2 hour, then we had an hour. So this was about a 4 to 5 hours worth of run there. And this was a course live scan, as I call it. I mean, we're marking in the field as we go. The way that we're able to mark in the field as we go is that we set up our range gain in the field, and we correct as we need throughout the day if that needs to change. We have to wait till we get back to the lab to know true depths, because we've got to calibrate for depth using our hyperbolas. And well, that's pretty much it. That's what we're seeing right there. So you're seeing these locations. These are known graves. There. All right. Well, thank you very much. And if we will get back out in the field.